Hi, my name is Jasper Kwejeheng, student ID 2106824, and I'll be presenting the background study. So, traditional aquaculture methods have significant limitations. They offer low returns, strain limited resources like land and water, and are highly susceptible to extreme weather events. Additionally, these traditional models are labor-intensive and unattractive for younger generations. The recirculating aquaculture systems, or RAS, helped reduce labor needs and boost production. However, they still face challenges such as the need for specialized workers, driving up costs again, and concerns over water and feed usage. This is where cloud technology comes in. Intelligent aquaculture integrates cutting-edge technologies like the Internet of Things, big data, artificial intelligence, powerful 5G networks, cloud computing, and even robotics to remotely control and automate the entire aquaculture process. In essence, intelligent aquaculture takes the guesswork out of fish farming as it aims to automate and optimize the entire aquaculture process from production to service. So for our first problem statement, in traditional aquaculture, there is a lack of real-time monitoring and management capabilities, leading to inefficiencies, increased operational costs, and environmental risks and pollutions. Without the constant data on water quality, fish health, and other factors, farmers might be wasting resources or missing opportunities to optimize their operation, which are inefficient. Also, due to the inefficiencies and lack of a precise control, can lead to wasted water, excess feed, or even unexpected fish deaths, which can drive up costs. Lastly, traditional methods can pose a risk to the environment. Without real-time monitoring of water quality and waste products, pollution can go unnoticed and harm the surrounding ecosystem. For the second problem statement, the current methods for monitoring water quality, managing feeding schedules, and detecting diseases rely heavily on manual labor and periodic sampling, which is time-consuming, error-prone, and inadequate for timely intervention. Checking water quality, adjusting feeding schedules, and monitoring for diseases all require frequent manual checks. This can be extremely time-consuming, especially for large farms or those with limited staff. Human observation is prone to errors. Subtle changes in water quality or early signs of diseases can be easily missed. And by the time the problems are identified, it will be too late for timely corrective intervention to prevent major issues like disease outbreaks. Early detection is crucial for preventing outbreaks and keeping fish healthy. Lastly, the objective and proposed solution. We can integrate an IoT cloud solution that can automate data collection, analysis, and decision-making processes to optimize aquaculture operations. Imagine a system where IoT devices continuously monitor key environmental parameters like water quality and temperature, while also providing insights into the health and behavior of aquatic organisms. By leveraging advanced analytics and machine learning algorithms in the cloud, this system can predict and prevent potential issues such as disease outbreaks or water quality fluctuations before they happen. This level of automation and real-time monitoring not only improves productivity and sustainability, but also increases profitability in the aquaculture industry.
Good day, sir. My name is Tan Ling Yi, and now I would like to explain the AWS architecture diagram. Here is the IoT sensor. It will detect the water pH and the water temperature. After collect the data, it will send the data to AWS IoT core and store in the S3 bucket. So for the first path, it will direct trigger by the Lambda to check the water pH and water temperature. If the water pH and the water temperature is out of range, then it will automatically send the Gmail to the user. The second path is we use the data in the S3 bucket to do the forecast. Here is the forecast that's used to predict the water pH, and here is the forecast is used to predict the water temperature for upcoming day. After forecasting, we use the Lambda to check the temperature and the pH whether it's out of range or not in the upcoming day. If yes, then it will send a Gmail to the user to alert them. We also have a quick site to let the user to build the water pH for each day.
Hi, my name is Chong Daniel, and my student ID is 2005608. Now for my part, I'm going to introduce to you AWS IAM. Now AWS IAM is a security system that controls access to your AWS resources. Of course, it allows you to manage users, groups, roles, and data provision that comes with your IaaS account. Now, first and foremost, we have users and groups. Now IAM allows you to create users and groups. We each have a unique security credentials. Now after that, we have roles. IAM roles defines a set of permissions for making AWS service requests. Now all these roles can be assigned to users groups for AWS services. Now, after setting the roles inside IAM, we can set a number of permissions. Now, IAM uses policies to define permissions. Now, policies are JSON documents that specify what actions are allowed or denied on which AWS resources. Now, of course, this is a security measure. Now, IAM enables you to securely control access to AWS resources. You can grant different level of permissions to different users, ensuring the principle of least privilege. Now, for our group, we managed to create the users, and of course, in order to get started on our project. Okay, so right here we have an example of our group's IAM's users. Here are our users, and here are the set permissions that I set to my group. Okay, here are the TCS group that we have created. Okay.
Now I will present about the AWS IoT Core. AWS IoT Core is a managed cloud platform that lets connected devices easily and securely interact with cloud application and other devices. In this smart water monitoring system, we will use AWS IoT Core to securely connect monitoring device to the AWS cloud. IoT Core provides features such as device shadowing, which allow us to synchronize device state across application, and device management, which help us to onboard, organize, and manage our device at scale. IoT Core also supports MQTT and HTTP protocol for device communication, ensuring interoperability with a wide range of devices. And now I will start to demo the IoT Core in our system. First, we will run this code in our system to stimulate, like publish the data from the device from the monitoring device to the AWS IoT Core. And then we run it. Okay, then we can see it successfully publish the data and then to the IoT Core. And it will publish the data in the interval of the 5 seconds. In that 5 seconds, it will pass one data into the AWS IoT Core. Okay, so then now we go to the AWS IoT Core. We go to the MQTT test file. And then here we need to enter the topic. The topic we can get from here is inside this code, we can set it so that we see what topic we need to monitoring the data, and then we put the topic here, and then we click subscribe. Okay, then wait for 5 seconds. Okay, we can see the data has successfully published inside here, and then we can see it will continuously to publish the data into here, just like stimulate the device sending the data to the AWS IoT Core. Okay, so this is the demo of the AWS IoT Core. Thank you. Now I will talk about the Amazon S3 bucket. Amazon S3 bucket is a scalable object storage service that allows us to store and retrieve any amount of data from anywhere on the web. In this smart water monitoring system, we will use S3 buckets to store data collected from IoT devices. S3 buckets provide durability, scalability, and security features such as access control and encryption, ensuring that our data is protected and available when we need it. And now I will demo. When we publish the data into the cloud, and then it will store inside the S3 bucket. Okay, so we go to the Amazon S3. Okay, now we click inside the S3 bucket, that we created to store the data, and then here is the file, means the 2024. This is the year. Then this is the month, and this is the date. Okay, then we can see every data we publish inside from the IoT device and then publish inside the cloud service, it will store inside the Amazon S3 bucket. And I setting it to set the data within 1 minute interval, so we can see from 135 and then to 136, 137, 138, 139. Okay, so we can also download the data by clicking it and then click this download. Okay, then we will download it and we can open it. And then we can see our record at here. Okay, so that's all for Amazon S3 bucket service. Thank you.
So now I will explain the first lambda it will connect to the S3 bucket so that it can check the water pH and water temperature. If the water pH is smaller than 6.5 and greater than 9, or the water temperature is smaller than 5 degrees Celsius and greater than 25 degrees Celsius, then it will send a Gmail to the user. We can press the test to trigger the Lambda. In here, I only check the latest row of the CSV file in the S3 bucket. So here, show that the water pH and the water temperature is out of range. And we can see in a Gmail, it was a Gmail to show that the water pH and water temperature is out of range.
Okay, now I will talk about the Amazon Forecast Service. Amazon Forecast Service is a fully managed service that uses machine learning to deliver highly accurate forecasts based on time series data. In this smart water monitoring system, we use Amazon Forecast to predict future water quality such as the pH value of the water. By analyzing the historical data collected from our IoT device and other resources, forecasts can generate accurate forecasts and provide insight that help us to monitor water quality. With forecast, we can easily train, deploy, and maintain custom forecasting model without requiring a machine learning expertise, allowing us to focus on solving real-world problems. And then now I will demo it. Since this forecast service is need to have the pay for the cost, so we just do it for one time and then we delete it. So the demo I will just show the picture of the result instead of go to the AWS LT, go to the AWS clouds to demo it. So just start the demo. So we can go to this is the console of the forecast, and then we can see our dataset that we have imported is at here. The first time we can create our dataset by clicking this button. So we have create the dataset, and then we just click it. Okay. Then it will ask us to import our data. Then after we have successfully import our data, and then it will show this, and then show this panel, and then we can train our predictor. And then after finish training the predictor, we can start to query our forecast by clicking this button. Okay, so after clicking the query forecast button, then we will go to dispatch, and then dispatch is we can select the which start date that we want to start to monitoring for the forecast data. For here, I have select the this date, and then the end date is this date. Okay, then we also need to fill the item ID. This item ID is the ID for the item. Just say we need to forecast which item, and then we just key in the item ID of the item to see for their forecast. And then after we fill in all this information, and then we click the get forecast. After we click the get forecast, it will show the item ID at here, and then it will show 3 lines. The first line is for the 90% accurate, and then the second line is for the 50%, and then this is the 10% accurate. We can set this percentage in the setting that place like that. But for default, I am setting the 10%, 50%, and 90% accurate. Okay, so if we don't want to see one of this line, I just say if I don't want to see the 10% accurate line, then we just click on this, and then it will hide it just like this. Right, so now we only can see the accurate 90% accurate line, and then the 50% accurate line. Okay, and then here will show about the date. Okay, and then so we can monitoring which date the pH value maybe will be higher or will be lower at that time. So this is for the forecast. Thank you.
After the forecasting, we also use the Lambda to check the water pH, whether it's out of range for the next day. In here, if the water pH of next day will be out of range, then it will send a Gmail to the user by today. So we can click the test to trigger the Lambda. It shows that the next day, the water pH will be out of range. So we can check our Gmail, and here is the message that used to alert the user. Same as this Lambda, which called Water Quality Monitor. It used to check the water temperature after forecasting. We can click the test to trigger it. Here show that the water temperature of next day will not be out of range, so it would not send the Gmail to the user.
So next we have Amazon SNS. Now Amazon SNS is a communication and coordination within AWS environments. Now, first and foremost, it uses a publish and subscribe messaging model. Now, publishers can send messages to topics, and subscribers receive messages from topics they're interested in. Now, of course, it is versatile. It supports a variety of messages formats, including JSON, text, and binary. Now, it can deliver messages to multiple subscribers simultaneously, including HTTP endpoints, email, SMS, and AWS Lambda functions. Now, of course, if you worry about scalability, don't worry. Now, it is highly scalable and can handle massive message volumes with low latency. Now, it automatically scales to accommodate any number of publishers and subscribers. Now, SNS ensures message delivery with built-in retry mechanism and support for message persistence. It also provides message delivery confirmation for each subscriber. Now, for integration. Now, SNS integrates seamlessly with other AWS services, such as Amazon SQS, enabling you to build complex event-driven architects. Okay, now let's look back to our AWS architecture diagram. Now, in order for users to receive notifications from the data, we will need to first create a subscription following an email protocol to be used for messaging. Now, next, we will need to create a topic for the data that we want to be notified. Now, for example, in our architecture diagram, we have forecasted data. Now we will have complete simple notification system for our proposed method.
And the last is the quick site. It just used to have an overview of water pH for each day, and the user can see the result as this picture.